Hello students, in this video we will talk about the Gibbs phase rule. Firstly, we have to discuss what is degree of freedom. We know very well that the degree of freedom is the number of external variables that can be changed independently without disturbing the number of phases in equilibrium. These are pressure, temperature, and composition. What does that mean? Out of temperature, pressure, and composition, how many variables that can be changed so that the phase equilibrium does not disturbed. So this is called the degree of freedom. For the derivation of Gibbs phase rule, we have to know about the component and phase. So what is the definition of component? It is a chemically independent constituent of a system. Number of components, the minimum number of independent species necessary to define the composition of all the phase present in the system. So what is the definition of phase? Phase is a state of matter that is uniform throughout in chemical composition and physical state. Now the Gibbs phase rule. What is the formula of phase rule? That is F is equal to C minus P plus 2, where is F represents the degree of freedom, C is the number of components, and P represents the number of phases at equilibrium for a system of any composition. Now we will derive the Gibbs phase rule. F is equal to C minus P plus 2. The degree of freedom F of a system is given by the difference of total number of variables required to specify the system and number of independent equations available to define the system at equilibrium. So degree of freedom is equal to total number of variables minus number of variables defined by the system. Consider a heterogeneous system having p number of phases like p1, p2, p3 up to pth phase and components of each phase like c1, c2, c3 up to cc. So the degree of freedom F of a system we defined as the difference of the total number of variables required to specify the system and number of relations between them at equilibrium. First we calculate the total number of variables. We know that we have 3 variables: temperature, pressure, and composition. To define the composition, suppose there are 2 components A and B in a single phase. If the molar concentration of A is known, the molar concentration of B can be simply obtained by difference. If a single phase having 2 components can be defined by a one concentration term. So similarly, a single phase containing 3 components can be defined if concentration of 2 components are given. What does that mean? अगर अपने को एक सिंगल फेस आ ਉਹਦੇ ਵਿੱਚ 2 ਕੰਪੋਨੈਂਟ ਨੇ ਆਪਣੇ ਕੋਲੇ A ਤੇ B, ਅਗਰ ਆਪਾਂ ਨੂੰ ਇੱਕ ਕੰਪੋਨੈਂਟ A ਜਾਂ B ਦੀ ਮੋਲਰ ਕਨਸੈਂਟ੍ਰੇਸ਼ਨ ਪਤਾ ਲੱਗ ਜੇ ਤਾਂ ਆਪਾਂ ਸੈਕਿੰਡ ਜੋ ਆ ਉਹਨੂੰ ਫਾਈਂਡ ਕਰ ਸਕਦੇ ਹਾਂ। 2 ਕੰਪੋਨੈਂਟਸ ਵਿੱਚੋਂ ਇੱਕ ਦੀ ਵੈਲਿਊ ਆਪਾਂ ਪਤਾ ਹੋਵੇ ਤਾਂ ਸੈਕਿੰਡ ਦੇ ਆਪਾਂ ਆਟੋਮੈਟਿਕਲੀ ਫਾਈਂਡ ਕਰ ਸਕਦੇ ਡਿਫਰੈਂਸ ਦੇ ਨਾਲ। ਸੇਮ ਅਗਰ ਆਪਣੇ ਕੋਲੇ 3 ਕੰਪੋਨੈਂਟਸ ਪ੍ਰੈਜ਼ੈਂਟ ਨੇ ਇੱਕ ਫੇਜ਼ ਦੇ ਵਿੱਚ ਤਾਂ ਉਹਦੇ ਵਿੱਚੋਂ ਅਗਰ ਆਪਾਂ ਨੂੰ 2 ਕੰਪੋਨੈਂਟਸ ਪਤਾ ਨੇ ਤਾਂ ਆਪਾਂ ਥਰਡ ਨੂੰ ਆਟੋਮੈਟਿਕਲੀ ਫਾਈਂਡ ਕਰ ਸਕਦੇ ਹਾਂ। ਸੋ ਲਾਈਕ ਦੈਟ if a phase containing 3 components, the concentration ਜੋ ਚਾਹੀਦੀ ਆਪਾਂ ਨੂੰ 2 ਕੰਪੋਨੈਂਟਸ ਦੀ ਪਤਾ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ, ਦੈਨ ਆਪਾਂ ਥਰਡ ਨੂੰ ਫਾਈਂਡ ਕਰ ਸਕਦੇ ਹਾਂ। So if a phase containing C components can be completely defined by C minus 1 concentration terms. If we have P number of phases, then the concentration required will be P into C minus 1. This is all about the concentration. But we have 2 other variables, that is temperature and pressure. We know that the phase diagram shows at equilibrium. At equilibrium, each phase has the same temperature and same pressure. So there is only one temperature and one pressure variables for whole of the system. So the total number of variables, that is equal to P into C minus 1 for composition plus 2 1 for one variable for temperature and one variable for pressure at equilibrium. So that's why we can add plus 2 for temperature and pressure. So this is the total number of variables. Next we find the number of variables defined by the system. According to thermodynamics, the chemical potential mu of a component is same in all phases when the system in equilibrium. So we suppose if a system consists of 3 phases, suppose A, B and C are the 3 phases, then for any component the chemical potential is equal to mu A is equal to mu B is equal to mu C. This equation we can also write as mu A is equal to mu B is equal to mu C. So if there are 3 phases like A, B and C, 2 equations are known for each components. So for P phases, the number of such relations is equal to P minus 1 for each component. Then for C components, the relationship will be C into P minus 1. So these are the total number of variables defined by a system, that is equal to C into P minus 1. Now we put the total number of variables, independent variables minus number of relationship between variables at equilibrium in the degree of freedom formula F. So F is equal to total number of independent variables are P into C minus 1 plus 2, and number of relationship between variables at equilibrium is C into P minus 1. When we solve this equation, the formula comes out F is equal to C minus P plus 2, and this is the Gibbs phase rule. Thank you.